Hi everyone, and welcome to this example. I'm going to take you through how you would use the bisection method by hand with the use of your CAS. As you can see, I've already got my CAS set up and ready to go because it's definitely going to help me work through the example. So the first thing I'm going to do is just going to go through the steps of how you would do the bisection method this way. The first step is to establish A and B, and A is just your left endpoint and B is your right endpoint. And generally B is always bigger than A, so as you would be reading a sentence from left to right, we're going to be working that way with our X values and our intervals as well. The next step is to find the corresponding Y coordinates that go with your A and your B. So you'll need to find F of A and F of B. The next step is then to find C, the midpoint of A and B. Remember, we're halving our interval, so we're then going to be checking to see what's happening between A and C, and then C and B as well. Not only do we have to find this midpoint, but we also have to find the corresponding Y coordinate, because remember, we're going to be comparing the Y coordinates, and we're interested to see whether the Y coordinates from the left endpoint and the right endpoint of our intervals have the same sign, so whether they're both positive or negative, or one's positive and negative. Step 5 is probably the trickiest of them all. Choose a new interval using the values of F of A, F of B, or in other words, using your Y values to make that decision from step 2. If your Y coordinate of your midpoint, your C, if that is negative, then it will replace the left endpoint if F of A was negative, the right endpoint if F of B was negative, and if the Y coordinate of your C is positive, it will replace the left endpoint if F of A was positive, or the right endpoint if that was positive. So your new Y coordinate will replace the old Y coordinate that shares the same sign. But I'll explain that as we go. And then with step 6, it's repeating steps 3 through to 5 until the required accuracy is reached. So basically you would continually check as you work the values of A, B, and C, and you would stop when all three of them are the same value correct to the number of places that's dictated in the question. So I do have an example, so I'm just going to scroll down a little bit so we can actually see it. I'll move my mouse as well. There we go. Okay, so here's an example of a question, and you'll notice that I do have a table set up. The table is there to help with the working out process. So, given that x cubed plus 3x plus 6 equals 0, has a root between -2 and -1, find the root to one decimal place with the bisection method. So in this question, we have our function, we have the interval that we're going to start with. We're going to start investigating between -2 and -1, and we need to continue the process until our A, our B, and our C are all the same to one decimal place accuracy. So in this working out, you'll see, let me grab a pen, the step 1, what's the left endpoint and what's the right endpoint? Well, our left endpoint is the -2. So this is our A. And -1, this is our right endpoint, and this is our B. So what we would be doing to fill in this table, the first thing is the left endpoint is -2, and the right endpoint is -1. The midpoint is going to be, well, we would add A and B and divide by 2 to find the midpoint as well. So with that being said, pop that down. I'm just going to quickly erase these. And what we want to do is try and use our CAS to help us out a little bit. Now we are comparing Y values, and I haven't found any Y values yet. So there are a couple of things you can do. One of the things that will save a lot of time, because you're going to have to continually substitute values into your function, is to define it first. And what you do is you, in a calculator page, menu 1, define, and I'm going to call this x cubed plus 3x plus 6, I'm going to call it f of x, because all of the instructions so far talk about an f of x. I'm going to call it that as well. So f of x equals, and we're going to put in x cubed and plus 3x plus 6. Okay, so we now have that. Step 1, and it's knowing what the first couple of steps is knowing what the y values are at the moment. So f of a would equal, for us in step number 1, f of negative 2. So let's work out what that's going to be. Now, because this is defined on my CAS, what I can do is I can type f, and see how it's bold? It means that it's defined as something. Bracket negative 2, and it tells me that it's negative a. And if I find what f of b is, I do that by substituting negative 1 into the formula, and again I'm going to use my CAS, negative 1, and I got positive 2, which is good. That's what I'm expecting to see, because remember, the solution will be between 2 points where the y coordinates are, or the y values are of opposing signs. So we've got a negative 8 and a positive 2. This is exactly what we need to know. Now, to use a table like this, what I like to do to keep track of what y value is positive and negative, the left endpoint, that's the one that has a negative y coordinate. So I'm going to put a negative here, or alternatively, if you want to make it super clear, is the left endpoint at the moment is the one with the negative y value. Above the above the right endpoint, I'm going to write down positive. And of course, if you prefer, just a negative and a plus. So now I'm going to keep track of it this way. And I'm going to be filling in my table. So, the midpoint. The midpoint is we add a and b, and we divide by 2. So, negative 2 plus negative 1 divided by 2. So negative 3 over 2. We will be using decimals because remember we have to compare to one decimal place. I'm just going to write it in as negative 1.5. And we need to sub negative 1.5 into the function. And remember it's defined. So f of 1.5. So you can type it another way if you're not familiar. If we want this previous answer to be substituted in, if you press up and have it highlighted and press enter, it'll bring it back down, press enter again, and we get negative 1.875. Okay, so we now have a new y coordinate that is negative. This means that the c value is going to replace the endpoint that also had a negative y value. So instead of us comparing between negative 2 and negative 1, because the left endpoint was the one with the negative, my left endpoint will now be my c value. So instead of going between negative 2 to negative 1, my solution is going to be hopefully somewhere between negative 1.5. So this midpoint will replace the endpoint that has the same y value sign. A negative y value will replace the endpoint with the negative. So the left endpoint was the one with the negative y coordinate. So now the process repeats. We're now comparing negative 1.5 and negative 1. So we have to find the new midpoint for that. So let's do that. And 1.5 plus negative 1 divided by 2, and we get negative 1.25. Okay, we're now needing to substitute this value in, so I'm going to use the trick from before. I'm going to press up, highlight, bring it down, press enter, move my mouse, there you go, and we get 0.2969. Now, the values over here don't matter too much in terms of how many decimal places you have to give. The main idea is we're checking to see whether it's positive or negative. So a couple of decimal places should be fine. I'm not going to go beyond 4, and I probably could have even had 3 there, but that's okay. All right. The y value is now positive, which means this midpoint, this negative 1.25, will replace the previous endpoint that also had a positive y value. So it's going to replace negative 1, and instead our right endpoint is now negative 1.25. The left endpoint will stay. And the process repeats. We're going to divide negative 1.5. Oh, sorry, we're going to add our answers first. So negative 1.5 plus negative 1.25. Divide by 2. And we get negative 1.375. We're going to sub this into the function. So f, pick that up, and we get negative 0.72, let's go 5. It's negative now, which means a negative 1.37 will replace this left endpoint because that also had a y coordinate that was negative. So I'm going to quickly fill in the rest of the table following that pattern, and I'll be right back. Okay, so I've gone ahead and filled in a couple of more lines following the same pattern. And remember, we're trying to find the solution correct to 1 decimal place. So here at line 4, which is what I did off camera, if we start to look at the first 3 columns and round these answers to 1 decimal place, we get, here it'd be negative 1.3, oh sorry, negative 1.4 in line 4, negative 1.3 and negative 1.3. So still a little off, but pretty close. Step 5, if we look at rounding these answers to 1 decimal place, we get negative 1.3, negative 1.3, and negative 1.3. So here at step 5, we actually start to see the same answer repeating itself, correct to 1 decimal place. And in fact, with line 6 and line 7, it's just going to reconfirm that the answer that we're looking for, so therefore x will be, so approximately negative 1.3, correct to 1 decimal place, and we saw that in step 5. So we had to do a couple of steps to get there. Now, obviously, with your CAS, it does make light work of this, but this is the process that you would follow until you find the value that the left endpoint, the right endpoint, and the midpoint all are equal to the correct decimal places as stipulated in your question. But that is it for this method. I'll see you in the next video where I'll take you through how to use your CAS spreadsheet.